So they're making a connect to the next piece. All right, it says Nate and Rick are discussing cars. Okay. Nate claimed that cars with lower odometer readings, that means cars with the lower mileage on them, because that odometer is the thing on the dashboard that counts how many miles a car has. Cars with lower odometer readings are worth more money, cost more. He's talking about used cars. His evidence was that his car with 23,000 miles on it was worth more than Rick's car with 31,000 miles on it. To investigate Nick's claims, the boys collected data from several car advertisements and made this table. However, they put the table in jumbled order. So the first thing we have to do is go rewrite our table. Okay, we've got to go redo their table from least to greatest. We need to go redo the table from least to greatest. I'm lining it up below the other table, so I'm keeping the same units, okay? That the left side is miles, that the right side is price, but we're gonna go rearrange what the boys did and put it from lowest miles to highest miles. So least miles to greatest miles. Okay, least miles to greatest miles. So what is the lowest miles they have on the table that they have? What was their lowest miles? Now, be careful and read what it says. Okay. Their number was 6, but is it 6 miles? Look what it says at the top. Did that 6 stand for 6 miles? What does it look at the top say? Oh, it stands for 6,000 miles. Okay. So it was 6,000 miles is worth how much according to their table? What's the number on the other side across from 6? 50. So if it only has 6,000 miles, then it's worth $50,000. Okay, what's the next one they had? We're rearranging their numbers in least to greatest order for miles. What's the next one? Don't need thousands because that's not the number on their table, and we're redoing their table from least to greatest. I know it stands for thousands, but we're not writing thousands on our table, and neither did they. Okay, so all we're doing is taking that one and rearranging it. Okay, so don't overthink it. Your data needs to be in order from least to greatest. If we're going to go ahead and look for a relationship, we have to have it in a sequence that makes sense. And this is mixed up. Okay, so how much was 15 worth according to them? 28. Now we have to keep in mind that these mean thousands, not $28, because it doesn't make sense for a car to be $50 or $28. But when we're putting it on the table, we're just reproducing their table in least to greatest order. What's the next one? We're reproducing their table in least to greatest order. So the next one is 28,000 miles, yeah. Is worth how much? $30,000, okay. So we're just rearranging. Keep going. What's the next one? 31,000 miles, yep. How many thousands of dollars were they saying? $35,000. Okay. Next one. $35,000 miles. How much? $38,000. Keep going. We have to keep rearranging, least to greatest. What's our next one? $50,000 miles, okay. How much did they say that one was worth? $26,000. Okay, next one. Got to keep going. We have to rearrange them all. Okay, 55,000 miles. What's it? How much is it worth? $16,000. Okay, what's our next one? $99,000 miles. Okay. How much? $10,000. Are we done? No, what's left? Oh, 99,000 miles again. Well, they found two 99,000s. Okay. Okay. So the best way, if we're just looking at raw numbers, the best way to go ahead and see a trend on a table is for the table to be least to greatest for the X. So this is our miles. Our miles, he says the miles, no. The miles affect the money. So the miles would be the X and the money would be the Y. Okay. That's how it works. Whoever does the affecting, oops, that's in the wrong spot. Get out of the way. Sometimes it hides stuff, so I can't see it. Okay. So whoever's doing which, because they say that the miles changing changes how much money, that's why the X is the miles and the Y is the money. They're predicting that miles change the money. Okay. So if we're looking at this new rearranged table of values, right? Does the information on this table support Nate's claim? And what we have to use the words that they already give us. So look at the two question marks, blend them together to give an answer. Okay, look at the two question marks, blend them together to do our sentence answer. Do we feel that this table, the information on this table, is supporting Nate's claim that cars with lower odometer readings cost more money? Do we think the table in general, not perfectly, but in general, does it look like there's a trend of that happening? That cars with lower mileage cost more? Does it seem like there's that trend on that table? That cars with lower miles cost more? Because that's what his claim is. Do you believe Nate's claim that cars with lower odometer miles cost more money based on this table of information? So you need to have a sentence answer, use the words that are already there in the question. Does the information in the table support Nate's claim? So how would we rearrange those words? Can we just pull the word does off and start our sentence starter? Does that work? Yes, so the information in the table supports Nate's claim. Now we have to say what the claim is. What was his claim? Look at the second sentence, question mark. The words are there. Start with the words Nate's claim and keep going. That cars with lower odometer readings, with a little, I keep leaving out that word a, lower odometer reading, cost more money, right? So you don't have to reinvent sentences for answers. You just pull the words out of the questions that they gave you. Now, does this perfectly show the trend, or do we see that there's a little space in there where it's kind of, it didn't quite follow the pattern we were expecting? Does anybody see a place in the table where it doesn't kind of really seem like it's following the pattern of lower miles equals higher price? Are there some cars in there that aren't fitting that pattern? That maybe their mileage is a little bit more than we'd expect the price for the car to be? Do we see any space like that? Where the price of the car is higher than we'd expect it to be? So are all of them perfectly low miles, high price, high miles, low price? Is that the perfect trend? That the price went from greatest to least? Every single price went from greatest to least? So if I counted down this list, they went perfectly from greatest to least? I mean, we could change this one up right here. This is an easy fix, making this one 10 and making this one 13, right? But do we see a place where the price doesn't quite fit? Where it seems like the price doesn't match with the theory? Where do we see a place where it goes 28,000 up to 30,000? This $15,000 car is only worth 28,000. That seems super low, right? What could be reasons why? What other factors can change the price of a car? If it's a used car, what's something else that might be coming into play that's making this $28,000 car happen? Do we only judge cars because of the mileage? Maybe its maintenance wasn't as good. Yes. Maybe it's a basic model, not a fancy model. Maybe it's a Hyundai, not a Mercedes. Okay, so these relationships aren't always perfect, okay? We're gonna look to see how we can make sense of them, knowing that it's not always perfect, okay? It's not always perfect. Now, it says, Melissa was wondering if a coordinate graph could help determine if the relationship in Nate's data from this, okay? So we need to graph these points, okay? It says that the odometer reading is the X. We already put that in there because the miles changed the money, right? The odometer reading is the X. And the price is the Y. We already have that labeled, okay? So, but it does say, set up the graph showing that the X-axis is odometer and the Y-axis is price. So I have to go put on here below the X-axis, which is the one that goes sideways. X goes sideways, Y goes up and down. Below the X, we have to say that it's odometer reading because it told us in the question, right? And we have to say in thousands, just like they did. And the Y is the price, right? Also in thousands, because we don't want to mess ourselves up thinking it's only 6 and, you know. All right, it says label equal intervals on each axis so that all data will fit on the graph. And we've had to do this before. This is where we have to figure out our scale. I see 3 people not in their cameras about ready to be removed. So fix that. Okay, so we have to figure out how many lines do we have? What is our biggest X? So how much do we need to make each line worth? Okay, so how many lines do we have going sideways to work with? How many lines do we have going sideways to work with? 15 lines. We have to make sure 99,000 fits on it. So what is the first number higher than 99 that divides by 15? The easiest way to figure that out is to do 99 divided by 15 and always round up. No matter what the decimal point comes out to be, round up. Then you take that number times the 15. So what's 99 divided by 15? Because we have 15 lines to work with. $99 divided by 15 is how much? Some of you need to refresh your cameras, please. 99 divided by 15 is how much? Use your calculator. But I need to round up to the nearest whole number. So what would I say? And then I multiply that times the 15 because that's how much each line is going to be worth. 7. So I'm going to put a little note for myself down here. So I remember each line equals 7. But how many is 7 times 15? Because that's what we have to put on the edge so people know how far our graph was going. 105. Okay. So now I got to go put my tick marks in. And each tick mark is worth 7. That's why we put this little note down here for us. And I'm going to zoom in because it makes it easier. We'll come back out when we have to go actually graphing. Okay, do the same thing for the Y. What is our largest Y? How many lines do we have? What is our largest Y? 50. How many lines do we have? 15. So 15 divided into 50. Round that up. What do we get? How many 15s are in 50? So we have to round up. That's what I said. I repeatedly said round up. And I meant round up. I didn't mean round. I meant round up. So how many, what is each line going to be worth? Because we have to round up. Because if we only do 15 times 3, are we going to have enough space for 50? So we have to round up to 4, no matter what. These are physical things. Remember, we talked about this before, that you have to round up so you have enough space to catch the number. What is 15 times 3? Would 50 fit? No. And since we need 50 to fit, we can't do 15. We can't do 3. We have to do each line is worth 4. So what's 4 times 15 worth? This is where it gets a little bit messing a little bit. Each line equals 4. 60. All right. So you have to remember, you always round up, no matter what the decimal is. If you have to fit your number in there, you have to always round up. Okay, go put your lines in going up and down now. Oops, not what I'm trying for. Right idea, wrong one. Okay, so go get your tick marks on there. So when you go to do scale, you have to take your biggest number divided by how many lines you have, round that up, and multiply it by how many lines to figure out how far out your graph went. That's what we did with the two numbers. We took the 99 divided by the 15, found out it was 6 point something, rounded it to 7, and 7 times 15 made 105. And then we did the 50 divided by 15, found out it was bigger than 3, rounded to 4. 4 times 15 made the 60. And then we put a little note for ourselves, how much is each line worth, because they're doing something different in each direction. And that's going to matter. That's going to matter. Okay, let me zoom back out. So we are going to graph this table onto this coordinate plane. That's what they asked us to do. Graph the table onto the coordinate plane. Put the dots on the graph to match the table. Put the dots on the graph to match the table. That's what it asks. Okay, so our first dot is how much? Remember that you want to be about 4. Our first dot is at what location? 6, 50. But how much is each bottom line worth? 7. So am I going to use the first line if I'm supposed to be 6? No. So we're not going to be actually on, most of these are not going to land perfectly on lines, and it's okay. They're going to be floaters. Okay. So what would 50 be if we divide it by 4? We know this one's just before the 1 line, right? Because the 1 is 7 and we're 6. But what's 50 divided by 4? What's 50 divided by 4? Use your calculators, guys. So it's between 11 and 12 and 13, right? It's not perfectly 12. It's not perfectly 13. So we're not on the first line. We're just before it. And we're between line 12 and 13. So this is 15, 14, 13, somewhere between. Do we have to stress that it's perfectly in the right spot? No. All we're doing is getting an estimate. All right. And we're putting that original stuff on here though, 6, 50. That dot is standing for 6, 50. We're going to repeat it. Okay. 15. Remember, each line sideways is worth 7. So is that going to land perfectly on one of the lines? 15? No, I cannot zoom in or I can't read my chart. So that's why you're following along with what I'm doing, not worrying about seeing exactly perfectly. Doesn't have to be perfect with Scatterplot. Because we knew for the first dot that 50 divided by 4, that's why we put the 4 in there in the first place to remind us how much each line was worth. Got us about there. So we do the next one. 15 divided by 7, because the bottom line is worth 7. Is it going to land on a line? Does 15 divide evenly by 7? No. Is it going to come close to a line? Because it's almost. Which line is it going to come close to? 2. A little bit more than 2, because 2 times 7 is 14 and 15 is just a little more, right? Okay, so we know that this is going to be a little more than the 2 line, right? But now we have to do the other number, 28 divided by 4. That's why we wrote ourselves that note, what each line was worth, so we could remember what are we dividing by to figure out what line am I supposed to make this land near. Does 28 divide evenly by 4? Yeah, which line? $28 divided by 4 is 4? I don't think so. Oh, 7. So a little bit past the second line, up to 7. 1, 2, 3, 4, 5, 6, 7. 28 divided evenly by 4. How handy. So that's 15, 28. Okay. I want to fill with white so I can see. It makes it easier. All right. Next one. 28 is the sideways number. What do we divide by sideways? What did we say at the bottom? What are we dividing by? 7. So 28 divided by 7. About what line would I be floating? Oh, that's exactly the 4th line. Yay. Okay. Then his other number is 30. What are we dividing the up and down lines by? What did we put up there at the top for how much we're dividing by? 4. So 30 divided by 4 is about what line? $30 divided by 4, about what line? So if we typed in 30 and we divided it by 4, what would we get for a decimal answer? 7.5, so it means halfway between the 7th and 8th line. Up the 4th line, 1, 2, 3, 4, 5, 6, 7, halfway between 7 and 8, because that's what our decimal says, halfway between 7 and 8. That's what 7.5 is. Okay. So the trickiest part of this is the scale thing, keeping it straight in our head. This was 28, 30. That's why we wrote ourselves the note though. Next one, 31, 35. So 31 is the left and right number. Going left and right, how much do we divide by? 7. So 31 divided by 7, about what line? Which line is it going to be closest to? Is it going to be closer to line 4 or closer to line 5? I don't think it's going to be close to line 5, because what's 5 times 7? Oh, it's closer to line 4, because what's 4 times 7? 28, and we want 31. Okay, so about between line 4 and line 5, yeah. 1, 2, 3, 4, somewhere between line 4 and 5. Perfectly, we don't care. Just estimating. Now we have 35 up and down. What are we dividing by up and down? What did we say? By 4. So if we divide 35 by 4, what do we get as a decimal? So we want to be getting our decimals just to figure out, am I closer to line 4 or closer to line 5? Am I closer to, or am I right in the middle? Okay, so 35 divided by 4 made 38, made 8.75. Is that closer to 7 or closer to 8? Oh, correction, closer to 8 or closer to 9? I don't know. What do we think? Is 8 point, if I'm 0.75, am I closer to the higher side or the lower side? Closer to the higher side, because that rounds up, right? 8.75 rounds up to 9. So I'm going to make my dot a little closer to the 9 line than the 8 line. So 1, 2, 3, 4, 5, 6, 7, 8, closer to the 9 line. But it's floating out there. I got to move my coordinate, it's in the way. They're floating out there. They're not perfect, and it's okay. We're not going for perfection. We're going to for estimating, because we're using this to estimate. Okay, that was 31, 35, right? Okay, what's our next one? 35, 38. So how much do we divide by going left and right? So divide 35 by it. What are we going to get? The 5th line. Oh, that's exactly on line. Yay! And then 38. We're going up and down. How much are we dividing by? 4. So what's 38 divided by 4? What's the decimal? 9.5. So that's halfway between 9 and 10, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, halfway between 9 and 10. This guy's getting in the way all the time. Okay? But on the graph, you have to put the numbers that were the real numbers. 35, 38. All right. So our next coordinate says 50, 26. So what are we dividing by sideways? Seven. So 50 divided by 7. Seven point what? 7.1. So just barely above 7. Okay, just barely above 7, right? So 1, 2, 3, 4, 5, 6, slightly past 7. Now we have to go up and down 26. What are we dividing by when we go up and down? Since we wrote our note at the top? 4. So 26 divided by 4. What's our decimal? 6.5, so exactly halfway. So 1, 2, 3, 4, 5, 6, a little past 7. And then up between 6 and 7. So 1, 2, 3, 4, 5, 6, halfway. And I'm gonna have to move this coordinate. The hard part, you have to keep moving these guys around. Okay, and we put our coordinates on it. Is it a big deal that it's not in the exact perfect spot? No, because we are going to use this to get an idea, a trend. 50, 26. Okay, what's the next one say? What's its number? 55, 16. So 55 is the left and right. What are we dividing left and right by? You're dividing by 7. So what would 55 divided by 7 be as a decimal? 7.9, so almost 8, right? Slightly before the 8th line, going sideways. So 1, 2, 3, 4, 5, 6, 7, 8. So a little bit before the 8, not perfectly. Now we have to go up and down to 16. What are we dividing each up and down by? 4. So what's 16 divided by 4? 4. So that one gets to be exactly on a line, right? Almost 8 and up 1, 2, 3, 4. Yay, that was a good one. I like them when they come out almost on lines or on lines. That's nice. So that was 55, 16. All right. So now we're on our 299s, right? So these are going to be straight up and down from each other because they're both 99. So once we figure out the sideways, that's going to be the easy part. They're both going to go up and down from that. It's the how far up and down. So where would 99 land? What are we dividing 99 by? Because we're going sideways? 7. So what's the decimal for 99 divided by 7? 14.1. So just barely past 14. So just barely past 14 out here, right? But then we have to go up and down. What are we dividing by up and down? 4. So I have to divide 13 by the 4 and 10 by the 4 because they're going to go up and down from each other from that 99 spot. So what is 13 divided by 4? What's its decimal? 13 divided by 4 is 3.3. So 1, 2, 3, and just a little bit more, right? That's a little bit above 3. How about 10 divided by 4? 2.5. So these guys are going 1, 2.5. So they're super close, straight up and down from each other. We got to do 2 for 1 because they both had the same x coordinate. 99, 13. And the other guy is 99, 10, right? Now that I don't have to be looking at both at the same time, I can zoom in. I just couldn't while I was graphing it. But do not stress that the points are perfect because it's a scatter plot. It's not meant to be perfect. It's super hard when the scales are not going the same and things aren't landing on exact lines, okay? So we followed the directions and we graphed what they told us to graph. Now we have to answer part A. that says, describe the scatter plot you just created. So you have to be describing, is it positive? Is it negative? And which one is changing? So is this a positive scatter plot? Both are going up. Or is this a negative scatter plot? One of our variables is coming down. Is this a positive scatter plot because both our variables are both going up? Or is it a negative scatter plot because one of our variables is going down? So positive scatter plots go up, negative scatter plots come down. So what do we think this is? Oh, it's a negative scatter plot. Because what? So this is a negative scatter plot because now we have to tell who's increasing and who's decreasing. Because negative would have one increasing and one decreasing. So who is increasing? Who is decreasing? Which one of our variables is going up while the other one comes down? What does that variable stand for? So which one, X or Y, is going up? The X is going up. What did the X stand for? Look below the X line. Odometer reading. So as the odometer reading went up, right? It's negative because as the odometer reading increases, right? We're using our math words. What's going down? And what does it stand for? Y is going down. What does it stand for? Yep. The price decreases. Okay, so that explained the scatter plot. We should have a comma here. Okay, so we described the scatter plot, right? We just did that. What do you notice about the points, how the points went on the graph? Did they all perfectly go always down? Do we have this perfect little cute line? Or a perfect flow? Or was there kind of a glitch in the middle? Okay. Did they all perfectly come downward? Or was there a glitch in the middle? So as every X got smaller, every Y got bigger. Okay, so what did we see happening? In general, did all of them fit the same perfect pattern, or was there some sort of wiggle? Some sort of area where it's a little bit not right, but not horrible. Still kind of doing the trend, we can see, but there's an area where things are kind of not in balance. Okay, so in general, is Nate's prediction correct? In general, as the miles got bigger, the cost got smaller, right? In general, but there was a little spot, remember we talked about it, that there's things other than miles that we look at. Okay, so they want us, with this information, predict about where will we put Nate's car. So we're going to change our dot color to red, please. Nate is going to be the red dot. All right. So Nate says his car has 23,000 miles on it. Using our pattern that we kind of see happening, about where should we put Nate's red dot? If his car has 23,000 miles on it, about where should his red dot go? Does it have to be perfect? No, we're just estimating. If we follow this pattern that's happening, about where would his 23,000 go? So how many lines over is the 23? Because that's a mileage, that's an X. How much am I dividing by for the X again? So about where? 23 divided by 7, what decimal do we get? $23 divided by 7, about what decimal do we get? 3.3, so a little bit in the middle, about 3, right? So we're about here, left and right. About how high should we go? What do we believe his car might be worth with 23,000 miles on it? Where would a dot fit in with the pattern? Where would a dot for his car fit into the pattern? How many lines up? Because we could put it on a line if we want to. About how much do we think his car might be worth? If we follow the pattern, move this back here. About how much do we think his car is going to be worth at 23,000 miles if we're trying to follow the pattern they gave us? About where would I put the red dot? Does it matter perfectly? Does it make sense though that it's way down here? 23,000 miles and only $8,000 because those are by fours, right? So think, about where should I put this red dot so it kind of fits in with the pattern of where the dots are? How high up should I go? How many lines up? About where? For 23,000. Look at the other dots. What would be a good spot to put the red dot in? Should I put the red dot way up here? Does that make sense? Okay, so Christian is estimating between the 6th and 7th dot. What would that be? How much would that be worth if it's between the 6th and the 7th line? A little bit more than 3. 1, 2, 3, 4, 5, 6. Between 6 and 7, he's saying put it about here. How much would that be worth then? If it's there, between the 6th and 7th dot. I'm making this one blue. This is Nate's car. He said 23,000 miles. About how much are we saying the car is worth then? If it's between the 6th and the 7th. How much is each up and down line worth again? So if he's between the 6th and the 7th, what would be a dollar value for his car? About. You're saying about 26,000 because that's between 24 and 28. Okay, that works for me. Okay, so we put a dot. Yes? So the rest of the question says, explain your strategy for how you placed your dot. So what exactly did we do? What exactly, how exactly did we figure out where to place our dot? Okay, explain our strategy in deciding where to place the dot. What was something we did? What was the first thing we did? And then what was the second thing we did? How did we figure out that we wanted to put that dot there at 26,000? What were we looking at to figure out to put the red dot where we put the red dot? What were we looking at to see why we put the red dot where we did? Why didn't we put the red dot way down here again? Why did this way down here not make sense? Why did the way up there not make sense? So what strategy did we use? Explain what we used. Explain what we did. We put Nate's car at how many miles? 23,000 miles and a price of about, what did we say? 26. Because, why? Why did we pick there? Why did we pick there? Well, why did we pick 26,000? Come on, I want to be able to move on. We have more to do. Why did $26,000 make sense? As opposed to putting our dot down here at 8,000 for 23,000 miles, or way up here at 50 or 40 something thousand. Why did it make sense to put it at 26,000? What were we looking at that made us say, oh, 26,000 kind of makes sense? What was going on around it that made us realize that? Well, isn't this true that if the miles get higher, then the price gets lower? So then let's put it at 8,000. That's miles getting higher, 23,000, price getting lower. There was something else we were looking at that said, oh, 26,000 kind of makes sense. It's more than just the higher lower stuff. Because I could have said 8,000, that's lower. That's a lower price. Why did it make kind of sense to put it at 26? What do we see going on that made 26 kind of make sense? As opposed to 8, way down here. There had to be some reason why we picked 26. It wasn't just blanket Leo, let's just go here. Look around at the points near it. Why were we picking 26? Why did that seem to make sense? What other points are near it that makes sense to have 23,000 miles be worth less money than something that's near it? What is the coordinate just before 23 at? Just before 23 would be a number smaller than 23. Right? So if we look at 28,000 miles being worth $30,000, isn't 28,000 miles a bigger number than 30,000 miles? Does this red dot make sense here? If 28,000 miles is worth $30,000, would 23,000 miles be worth less than that? Does that make sense? Does it make sense for something that has more miles to be worth more? Because that's what we're saying, 23,000 miles is only worth $26,000, but 28,000 miles is worth 30. Does our $26,000 make sense? What was Nate claiming was true? As the miles go up, the price goes down. Does it make sense that 28,000 miles would be worth more than 23,000 miles? As the miles go up, the price comes down. Should a 23,000 be worth less than a 28? Who is smaller, 23,000 or 28,000? 23,000 is smaller, so that's less miles. So as the miles go up, the price goes down. So should a 28,000 mile car be worth more than a 23,000 mile car? If 23 is smaller than 28, then 23 should be worth more than 28. Is that what our red dot is saying? Since the worth is on the up and down. Is our red dot higher than 30? No. So do we think our red dot's in a good spot? So what should it be based on the information around it on the graph? That's what I kept saying. Does it make sense for 23,000 miles to be worth less than a $28,000 mile car? No. So it shouldn't be 2326. It shouldn't be worth less. It should be worth more than the 28,000. A lot more? It's dependent on you. You need to get this red dot somewhere where it makes sense with the trend. Does it make sense for the red dot to be down low? Does it make sense for the red dot, 23,000 miles, to be lower than one's higher mileage? No. So where should we be putting this 23,000 mile car? That makes sense with the trend. Look where would make sense. Shouldn't be below these ones that are higher mileage than it. Because we said high mile equals low cost. And 23 is not high miles. Where's a better place to put it than 26,000? So that it fits with the pattern that we see is happening. So what would mileage would that be? How much would that be worth? $32,000. Do you see ones around it that are higher mileage and more than 32,000? So if we're going for the same kind of trend, low mileage equals high price, where would be a good spot to put it so it fits in with the trend that's happening? Because my trend is starting high, going low, This is a medium number. It should be landing somewhere in the middle of the mix. So about where do we think we should put it? Look at the trend of the numbers near it. About where should this 23 land? Should 23 back be up here at 50? No. Should 23 be down here at 16? No. Look at the trend of where the numbers are landing. About where should we put the 23? Should it be lower than something with 35,000 miles on it when it's 23,000 miles? Does it make sense? No. So about where should we put the red dot? Going up from 23,000 to where? How much about do we think it should be worth compared to the other things on the graph? Remember, we already said that that 15,000 was a extra. He wasn't quite right. Ignore that one. Ignore that 15. Look at the 30s and the 20s. About where should we put it? Higher than a 35,000 or lower than a 35,000? If it's 23, would I want its money be worth higher than 35,000 miles or lower than? Would a $23,000 car be worth more or less than a $35,000 car? Because more miles, according to what Nate says, is worth less. Does it make sense for the 23,000 mile car to be valued less than the $35,000 car, 35,000 mile car? Does that make sense to make it less? So about how much do we think a 23,000 mile car should be? More or less than $38,000? Because this was 6 worth 50. This is 35 worth 38. 23 is between there. Yes? So we should have a dollar value between there to make sense with the trend. So how much do we think this 23,000 mile car should be worth if we want to be between 50,000 and 38,000, somewhere in there? So choose a number between 50,000 and 38,000. I recommend something that divides by 4. Because then it'll land on a line. Someone pick a value between 50,000 and 38,000 that can easily divide by 4 so we can move on. Fine. What line would it be then? 10th line. Why are we picking 40,000? Think about what we just talked about. 15, 14, 13, 12, 11, 10. Why are we putting it between here instead of down where we were thinking before? Why does this new dot make the most sense? What are the 2 miles it's between? So what should the dollar value be between? Look at the information on the table. Why did we put 23,000 here? Why did we say this makes the most sense? What 2 miles on the graph was the 23 between? What 2 odometer readings is it in between? What 2 points that we'd already graphed is the 23,000 between? That's money, not miles. What 2 odometer readings is the 23,000 between? We're asking what x's is our 23 landing between? What x was connected to 56? What x was connected to 38, 35? So what did the 6 mean? What did the 35 mean? What mileage was 23,000 between? Six miles? No. What are the miles being measured by? 6 what? What does it say the miles are measured by? It's not just 6, it's 6 what? 6,000 miles. And what was the other one that we were comparing it to? What was his miles? 35,000. So it makes sense that the value is between, what are the 2 money values? What was the 6's money value? What was the 35's money value? Because we said 6,000 and 35,000, what were the 2 money values we were looking at to make our 40,000? Okay, between 38,000, oops, and 40,000. Oh, 50,000. Right. Sorry, that's what we had to look at. Okay, my 23 is landing in between here, so its dollar value should probably land in between here too. We already had talked about this 15 wasn't right. There was something wrong with it. Okay, when a relationship exists, okay, and we believe there is one that exists, that there is a connection between the miles and the dollar values, that is called a line of best fit. Okay, this line does not need to touch any of the actual points. Instead, it just shows the general idea of which way it's going. Okay, so we have to decide where to put a line of fit into our data. Now, it's really important to remember that we want, I'm going to change to a green line, please. We want our line of fit to stand out. When we are looking at our line of fit, it can cross through original dots, but it doesn't have to. And if it doesn't fall between original dots, we need to make sure there's about the same number of dots on both sides. Okay, so A line of best fit, don't do this one, I'm just showing. A line of best fit up here doesn't make sense because there's no dots above it. Okay, that's not going through the middle. The line of best fit needs to go through the middle. A line down here also would not make sense because there's no, it's not going through the middle. Okay, so when you think of line of best fit, you're thinking about how can I cut through the middle of my dots so I have about the same number on both sides of the graph. So if let's look at a couple different options. We could do this one, you don't need to do it yet. If we do this line of best fit, is there about the same number above and below the green line? Do we have about the same number of dots above and below the green line if we put our line there? Because the line of best fit is personal, it's just an estimate. So if I count the number of dots that are above the green line and I count the number of dots that are below the green line, does it split that number so they're both the same? How many dots are above the green line in this situation, including Nate? Do not bother putting lines on your graph yet. Answer the question. How many dots are above the green line in my picture? How many dots are below in my picture? Are those the same number? No. So this is not a good spot because we needed the line to cut through the middle. So it has the same number above and below. So we have to try again, and it's okay. So let's try again. If I put my line of best fit here, do I have about the same number above and below? Yes. So add your line in like I just added mine. Put it in the same spot. So the whole goal of the line of best fit is to get down the middle. So it's about the same number above and below. So put yours in the same spot as mine. Yes, make it a green line, please. So it looks to me that this is 1, 2, 3, 4, 5, 6, 7, 8, 9. Between the 10th and 11th line is where it starts, and where it ends is between just a little above the second line. So you start at the Y line, stretch it all the way to just a tiny bit above the second line over by the X. Make sure that that one dot is not on it. It's between those two that are the 99,000. Okay. So decide where the line of best fit goes. Are there any limits that make sense? What did we just say? Where do we have to put lines of best fit? The line of best fit needs to go where? Above everything? Below everything? Through the middle of it? What? Where does the line of best fit need to go? Where does the line of best fit need to go? Does it go above the data, below the data? Where does it go? We don't need to know specific lines. We need to go general. It's general. The line of best fit needs to go where? What did we decide? How does it have to draw? Where does it have to go? Above my data, in the middle of my data, below my data. So I have this, what's going on? What did we just talk about? Through the middle. 1 second. Of the points. Don't go unless you want to risk it. so that what had to happen? Through the middle, and what had to happen? About the same number of dots. Yep. Are above and below. Oh, spelled that wrong. They're risking it because I'm going to be telling you guys something that you need to have done. Okay. So this is due at 12:46. That means you have to finish part D, E, and do number 16. I'm going to be doing tutoring after school at 2:30. Okay. If you come to tutoring, you'll be allowed to turn it in late after tutoring, no penalty. But if you don't come to tutoring, you need to finish it and have it done by 12:46. So your choice. Finish it by 12:46 on your own, get it turned in. Come to tutoring after school, get it finished, turn it in. If you don't turn it in, it's a 0. Okay. So have a good lunch.